determined workers.
All right, good evening, ladies and gentlemen. Welcome to the ASVAB weekly installment series. Today we're going to talk about mechanical comprehension essentials. Just like the electronics, I'm just going to give you a little bit at a time. I'm not going to slam you with like an hour long or a half hour long. I don't think this will be a half hour long video, but a lot of people are not really mechanically inclined. So if the job that you're seeking you might want to learn a mechanical job, and so what you have to do is score enough points in order to appear to be trainable. So I'm going to give you some mechanical comprehension essentials to help you kick butt on that side of things. And like I said, it'll just be a little bit at a time. You'll be spoon-fed, if you would. But the first thing we're going to talk about, the classes of levers. Lever or lever, however you want to pronounce it. But I call it a lever. And a lever is just basically, it's a simple machine. Any machine, by definition, a machine is any device by which we apply a force at one point and it's used to overcome a force at another point. So that's our definition. And so a lever is it's a simple machine because it's helping us do work. So first one is a class 1. It's the most simplest lever, and we need to pay attention of three things when we talk about levers. We need to look at where a load is. We need to think about where effort is applied, and we need to look at something called a fulcrum. And a fulcrum is basically a pivot point for our lever. So lever. So what is a lever? It could be a long bar, a stick, a plank. It could be a lot of things. But for a first class of a lever, all I want you to do is think about when you were a kid and used to play in the playground, and you would play on something 9 times out of 10 called a seesaw. And the seesaw is our first example of a class 1 lever. Okay, so you remember you had 2 kids, but first off, let's look at this. This is the fulcrum or pivot, and then 2 opposing forces are balanced on both sides. So this is the first class. And you want to think of an effort being applied on this side and a load being applied on this side. So you have your fulcrum or your pivot point in the middle, and you have an effort and a load being applied. So we're thinking about this as a machine. Now, in theory, there's 2 kids here on this seesaw. All right, and we know that they're balancing each other out. But just think of this kid. Before this kid got on, there was a load being applied, and it was tilted this way. So then when this kid got on, it applied effort to the machine, and hopefully it balanced out. Okay. Another example of a class 1 is I don't know if you've ever opened up a can of paint, but if you open up a can of paint, just watch, because we have the fulcrum, we have a load, effort being applied here, a load being applied here. If you would, and they could be flipped around, but but the fulcrum separates them. That's the important part. E, F, or I'm sorry. The effort could be here. I said EF. It could be EL, effort, load, the fulcrum. The load could be here. The effort could be here. But the idea of class 1 is the pivot point separates the class 1 lever. Okay. Another example could be of a class 1 lever is, like I said, if you ever open up a can of paint. Well, we're looking at the top of the can of paint, and you got the paint can here, and you got the lid. It kind of goes into the paint can, right? So what do? You come here to open up the can of paint. So you come in with a screwdriver, and you plug it, you pierce it into there, okay? So here's the effort. It's going to be applied downward. The pivot point or fulcrum is here, the edge of the paint can. And then the load is being applied here. So the fulcrum is separating the load and the effort, because our effort is going to be to move this down. So this comes out and it actually lifts the lid. Okay. Another example would be, let's say we have, I don't know, a big crate or something, and then we have a rock here or a block, and let's say this thing was like 1,000 pounds, right? Well, what we could do, and this is a shoulder, and that's a hand holding the crowbar. So this is the load. We're trying to tilt. This is the fulcrum, whatever rock or something's in here. And our effort is going to be applied downward. So just like the seesaw, we have a downward force acting here. The pivot point or fulcrum in the middle, and we have a downward force here. So we could call this the load. We can call this the effort. Effort. But the thing is, like I said, I say again, the balance, the pivot separates the load and the effort. All right. So that's the class 1 lever. And always think seesaw, fulcrum in the middle for class 1. Class 2 lever. Now class 2 and class 3 have something in common that I want you to pay attention to, and that is the fulcrum is going to be on the end of our so-called seesaw plane, and the load is going to be in the middle, and the effort is going to be applied upward. I'll put EFF to abbreviate. Okay, so you got to think, what looks like a class 2? What kind of situation would a class 2? Well, think of a wheelbarrow. My stick figure. Okay. Think about the wheelbarrow. The fulcrum is here, just like in our example. The load or weight of the materials is there, and the lifting or upward effort is applied there. So we have the balance point, the load exerting a downward force, and then we lift. Now, the reason why this is easy is because of the distance from the fulcrum to the upward force. The closer we get, the more force we would have to apply. But the further away we get, the more mechanical advantage we have. And I'll talk about mechanical advantage in a minute. Or I could talk about it now. Mechanical advantage is the factor by which a machine multiplies the force applied to it. So us being all the way back here is multiplying the force. Maybe I only need, let's say this is 200 pounds of gravel or something in here. Well, I only need to apply 50 pounds of force upward to lift this 200 pounds. And then I have the wheel so I could actually roll it around. So it makes it easier than if this man was to just grab a crate weighing 200 pounds. Puts it in the wheelbarrow. His distance, the more distance he has away from it, makes it really, really super easy. If trying to think of something else, think about a rickshaw. Have you ever seen a rickshaw? You know, in Japan, you have a rickshaw where the man, and there's a lot of distance where you have like the wheels here, and you have very, very long handles or wood planks coming out, and the man actually moving it around, and you could have two people in here. Okay, so that's the rickshaw. But we have our fulcrum, our load is applied, and our effort is being up here. So this man doesn't really need that much effort to apply to carry these two people. Now, if this man had these two people on his back, he'd be struggling. But the rickshaw is the machine that helps multiply his effort. Okay? So he has a mechanical advantage because he applies force and the machine multiplies that force. It gives him an ability to carry around and roll two people. Okay, but fulcrum, load in the middle, effort at the end. All right. Class 3. The effort and the load switch. Effort here, load, I'll just abbreviate. Effort in the middle, load there. Alright. So, let's give you a good example. A broom. A broom. Let's take this and rotate it upwards. This is a broomstick. Alright, I'll put the broomstick here. Alright. Fulcrum is here. Effort is being applied here. And the load that you're sweeping against is applied here. Okay, we take this and we turn it up, right? And now the broom is upright. Checking our real estate. And this is the broom on the bottom. The debris is, let's say we're sweeping the debris on this side, right? So the load is gonna exert its force against the effort. All right, so the balance point, the fulcrum, is up here. The effort, or my bad, trash is on this side. All right, so the effort is being applied in this direction, and the load that it's fighting is actually exerting a force in that direction. Okay, that is a third class lever. Another example of a third class lever chefs may be familiar with this, and I'm sorry, Fulcrum, effort, my bad. Effort and load. Okay, and chef, you ever see those tongs that you take and you grab food out? Like, let's say if I had a pot here, and I don't know, I had some food in here or whatever, and I don't want to reach in there with my hands. Well, I don't have to reach in there with my hands, and I could take the tongs, dip it into the pot, squeeze, and pull whatever food I needed out. But at any rate, for the third class, over the tongs, they kind of go into the pot like this, right? And the fulcrum will be up here. The effort, me squeezing the tongs together, would be in this direction, and the load would be considered to be in that direction. Alright, and the balance point theoretically would be like this in this case, because the load kind of reacts opposite of the balance point, how we look at it theoretically. But still, the effort is in the middle, in between the load. So, to remember, first class is the seesaw. Effort and loads are on the outside. Let's think of class 2 as ELF, E-L-F, all right? The fulcrum is here, E-L, load is in the middle. So, and the wheelbarrow is a great example of this. Okay, here's the wheel on the bottom, we actually lift up against the load. And the third class, just think of ELF, and still the fulcrum is on the outside. The effort goes into the inside, the load goes onto the outside. Okay, and a broom. So seesaw, wheelbarrow, broom is how I would use a memory aid to understand. So now, for mechanical comprehension, they have tests regarding, okay, they may put a seesaw up there and they'll ask, what class lever is this? Okay. So that's all I'm going to give you for right now. In the next video, Mechanical Advantage, we're going to talk about load moments, things of that nature to help you execute weight and balance problems. So thanks for checking out ASVAB Weekly. This is the Mechanical Comprehension Essentials. You're going to need this stuff. And like I said, rewind this, and just take your time with it, because it's a lot to learn. If you are not mechanically inclined, you can be prepared for the test at least, because you may be looking for a job that involves mechanics, and so you want to do really, really well so you can be, or appear to be, trainable. Okay, anybody can learn anything, but if somebody's mechanically inclined, they'd be more to send them to a certain school to, I don't know, work on tanks or work on vehicles, diesel engines and things of that nature. So that's all. This is Kieno Thomas. Thanks for watching. Have a great day.